In the last lesson, we looked at finding solutions to functions and then graphing those solutions. In this lesson, we're going to look at what if we come across an equation that is not written in function form. It has an x and a y, so it could be written into function form, but it's not written that way yet. We're going to look at how to change the equation around and get it into function form. Before we do that, let's review just the big ideas that we've learned so far. First, we learned that relations are a set of ordered pairs. And we learned that a relation is a set of ordered pairs where the inputs do not repeat. And when the inputs do not repeat, this is called a function. We learned that in a function, the input value is the same as the x-coordinate in an ordered pair, and the output value is the same as the y-coordinate in an ordered pair. So when we come up to our solutions for functions, we write them as ordered pairs. All functions and function rules are written in the format of y equals mx plus b. The y is first, then an equal sign, then something x plus or minus another number. We're going to look at today, as I said, what if an equation isn't in this form? How can we get it into that format? Let's look at this equation, 4x plus 2y equals 12. Is this in function form? Is it in the format of y equals mx plus b? Hopefully you notice right away that it is not in function form. So let's consider how can we alter this equation and get it in function form. The first step that I would suggest is find the y in the equation and circle it. Find the y in the equation and circle it. So here is y. We want to get that term all by itself. We want y on one side of the equation all by itself. So let's consider, if we want to get y by itself, 4x plus 2y equals 12. Let's take away 4x on both sides, right? We have to keep it balanced. Now, notice how I wrote that. On the left-hand side, we can actually work the problem. 4x minus 4x is 0, leaving only 2y. Then our equal sign. On the right-hand side, I simply wrote 12 minus 4x because I can't solve that. These are not like terms. So I just wrote it there, not actually to solve it. Now, let's look at step 4. If there's a number with a y, get rid of it. So we notice here it says 2 times y equals 12 minus 4x. Well, we know if we're trying to eliminate that variable 2 that we need to divide everything by 2. Now, let's look what we have when we're done with the division. We have y equals 6 minus 2x. Now, is this in function form? Well, let's consider what is function form. Y equals mx plus b. So we're very close. Our x term needs to be first. So let's just flip the order here. We're going to have y equals, let's put the negative 2x first, negative 2x plus 6. Now it matches function form. So we have transformed the equation 4x plus 2y equals 12 into function form y equals negative 2x plus 6. So let's try that process with example 1. Remember, an equation in function form begins with y equals mx plus b. So here is our y in equation number 1. We want to get that by itself. So in order to do that, let's take away x on both sides of the problem. That will leave us with y equals 8 minus, I'm going to write that as 1x so that there's a number in front of the x. Now, Function form says that after y equals, we should have the mx. So let's take the mx part and let's write that first. Y equals negative 1x, and then the plus b, that's a positive 8, so we'll write that as plus 8. We now have this equation in function form. Let's try that with example 2. Remember, we're working to get it in y equals mx plus b format. In order to do that, let's get this y by itself. So let's add 3x to both sides, so that now we have y equals 11 plus 3x. If we look at that, is it in function form? No, but it's very close. If we make it y equals 3x plus 11, now we've accomplished getting that equation into function form. Let's try example 3. In example 3, we have the y located in the correct spot. But it's not just y equals, it's negative 12y equals. So let's think, how can we get y by itself? Well, we can divide by negative 12 on both sides of the equation. Dividing by negative 12 will give me y equals, now 4 divided by negative 12 is not a whole number, that's going to be a fraction. 4/12 is a fraction, but I can reduce that. I can reduce that fraction to 1/3 x. And notice there's a negative sign there. I'm going to go ahead and leave it written in the denominator, although if you want, you can write it in the numerator. So we have y equals negative 1/3 x plus 24 divided by negative 12 is negative 2. This equation is now in y equals mx plus b format. It's in function form, so we're finished. Now, there's one more example. 5y plus 3x equals 15. I'd like you to try getting that equation into function form. I want you to get it where y is first, then we have our mx and our plus b. Complete that, and then submit the notes to Seesaw. We will check over your answer tomorrow when you come to class, but please make sure you have completed this example.